Okay, this is Mr. Anderson for Kellogg Community College. This is our second video, or second part of Chapter 2, where we're going to spend time taking a look at relative frequency histograms, relative frequency polygons, and relative frequency ogive plots. So what we're going to do is take a look at this data, which is the proteins, the protein grams in fast food. There are 50 pieces of data here. And what we're going to do is take a look at how this data basically fits into percentage. Now they would use percentages with very large amounts of data here, but what we have is kind of a shorter amount, and I misspoke where there is exactly 40 pieces, not 50 pieces of data here. So we'll start out by doing what we did on the previous video. We're going to look for a maximum, which in this case is 57. We're going to look for the smallest amount of protein in the fast food data, which in this case is 12. And the range between the two of them, or high minus low, is going to be 45. We are then going to take, the book's suggestion is to do this in 6 cases. So we're going to take our range and divide this by the number of cases, and this will tell us how big the interval should be between each bar. And the interval should be, if you do the division here, is 7.5, so we're going to round that up to 8. So 8 is going to be the distance in each of our classes. Now, our minimum here is 12, but according to the bounds of 12, if you make a boundary of 12, it would go from 11.5 to 12.5. We're going to make that class start at 11.5. And we're then going to go all the way up 8 units to 19.5. And then from 19.5, we're going to go up 8 units to 27.5. And then we're going to continue this pattern until we get 6 intervals here. And this is going to be 35.5. 35.5. Another 8 will be 43.5, and I have to go 2 more spaces here since I have 4 classes now and I need 6 total. This is going to be 43, sorry about that, 43.5 to 51.5, and our final case is going to be 51.5 all the way up to 59.5, which covers our maximum. So we're going to then talk about the frequency here. How many pieces of data were between 11.5 and 19.5? Now I've done the counting for you, and there were 7 pieces of data, or 7 items with between 11.5 and 19.5 grams of protein. There's 7 of those in this range. There was 17 within 19.5 and 27.5. There were 10 between 27.5 and 35.5, and there were 4 between 35.5 and 43.5, and there's 1 in each of these categories here. Now, the relative frequency. What we'll do is take the quantity here and divide it by the total to get our percentage. So 7 divided by 40 will give us a decimal of 175 thousandths, or 17.5%. Now, to give you a little bit of a help here, I would keep this in 3 decimals and then follow suit with all the others. 17 divided by 40 is going to be 42.5%, or 425 thousandths. 10 divided by 40, I wrote down 14. Oh, silly of me. Sorry about that mistake. 10 divided by 40, that is going to be 25%. Now, to make things a little easier on yourself, put that extra 0 in there. The book will do that because when you start to make your histograms, frequency polygons, and ogives, you'll kind of like the fact that there are all these thousandths of the decimals in there. Then the 4 out of 40 is going to be 10%. But again, let's add our zeros on there so we have some nice synergy there between all these. 1 divided by 40 is going to be the same thing for the last 2. It's going to be 2.5%, or 25 thousandths. Now, all of these will add up to 100% if we do that. Now, I'm going to save our cumulative relative frequency here until we get to the very end. So let's go to the histogram. Now, you can kind of see that I've got set up for us here. Our histogram classes will go on our x-axis. And I won't neglect when I get to the end of this here to label our x-axis as to what we're talking about. And 43.5, 51.5. Don't forget your upper bound here, 59.5. Okay, that's all in there, and make sure to label your axis. We're talking about protein grams in the fast food. Okay, back to the start here. This is going to be, instead of frequency, this is going to be relative frequency. And this is going to be in a percentage. Now, percentages go from 0 to 100%, but I'm going to take just a moment and look at my chart here, and I notice there's nothing over 42.5%. So instead of needing to go to 100%, maybe the top of this I could go to 50% or 0.500. That's 50%. This is 40%, 30%, 20%, and 10%. So between here and here, I know you'll want to look at this column to say, oh, it's 7 blocks tall, but we're going to kind of use this as a percentage. It's 17.5%, so 175 thousandths. So between 150 thousandths and 200 thousandths, that's where that bar is going to be. And again, do that to help us grade your paper, so we won't have to strain our eyes so much to see where you landed. All right, this next bar is going to be 425 thousandths. May have made that a little on the tall side. And this one is going to be 250 thousandths, or 25%. That means that of this data, 25% of the fast food is between this range of 27.5 and 35.5 grams of protein. Then we're going to move to the next level. It looks like the higher we go up, the harder this will be to get this much protein. And then finally, our last two bounds are going to be 2.5%, which is 25 thousandths. All right, and there we have our relative frequency histogram. Looking good, looking good. Now we're going to create our relative frequency polygon. Probably should have the word relative there, right? The relative frequency polygon, what we're going to do is take our 11.5 and our 19.5. We're going to add those together, and then we're going to divide by 2. And when we add these together and divide by 2, we get 15.5. Okay, we're going to add the 19.5 and the 27.5 together, then divide by 2, and we get 23.5. You'll notice the distance between those is 8. The distance between these is 8, so I'll do one more the old way. 27.5 plus 35.5. If we add those up and divide by 2, we get an answer of 31.5. And now you can also take the pattern of just adding 8 each time. 39.5, 47.5, and 55.5. And let's go. This will basically tell us all the data that's in between these two sets here. Okay, so how many pieces of data were between 11.5 and 19.5? Well, there were 7 pieces of data, but since this is a relative frequency polygon, the left-hand side will not be marked by 1s. These will have to be in relative frequency or percentages. Now, just like the previous chart here where we went to 50%, we will do the same thing. So if you see on your homework, if it talks at all about relative frequency, you're going to be doing percentages. So here we go. 15.5 is going to be at 0.175, so right here. 23.5 is going to be all the way up to 42.5% or 425 thousandths. And this is going to be at 250 thousandths or 25%. And we have this at 10% or 100 thousandths. And then these last two. All right. And I did have a really good question in class, because you'll notice that when we get to the end of this relative frequency polygon, you'll notice that this 55.5 is actually lower than our maximum. But this was derived by looking at the difference between 51.5 and 59.5, and since this number it isn't bigger than the maximum, but it also tells me that this is approximately where it's at. It was derived by looking at the range where the maximum would have been. So that kind of gets around a question that was talked about in class today. A great question. And before I leave, I probably should put down what this is. This is protein grams in fast food. All right. Now we're almost done with this page, but the ogive, this right here, is going to be talking about cumulative frequency. Now the cumulative frequency is adding up all of the relative frequencies, and when we get done, we will have a total of 100%. So the amount that was less than 19.5%, or sorry, I made a mistake there. The amount of the number of fast foods that had protein that was under 19.5 grams was 17.5%. Now, if I'm looking at those that were less than 27.5 grams of fat, if I add these two numbers together, this one and this one, makes a total of 60%. Now, how many or what percentage of this data had less than 35.5 grams of fat, or sorry, grams of protein, and we would add these three numbers together, 1, 2, 3. If we add those together, it turns out to be about 85%, or 850 thousandths. Okay, and we can keep going here for my 6 categories. Let's write those down here. The 6 classes, this is 43.5, this is 51.5, and then 59.5. Boom, 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 boom. And then we have 950. If you added up 1, 2, 3, 4 pieces of data, 95% of the data is there. 97.5% of the data is all the way here. And then when we get to the final part, we have 100% of the data is included at the total. Now, from the previous video, this graph is going to look like a ski slope. But you'll notice that the cumulative frequency went up to 100%. So we're in this case going to treat every single tick mark like 10%. And we're going to keep consistent by showing all 3 decimals here in our problem. So start off with 11.5, move up by 8 because that was our interval determined by the number of cases that we had. All right. And don't forget to label the graph. The protein by the gram in fast food. And on the left-hand side, this is going to be our relative frequency. Okay. So, going back up here, food less than 19.5%. Sorry, food with less. Sorry, I got to start that over. food with less than 19.5 grams of protein, there was 17.5% of the data under that range. So under 17.5%, or 175 thousandths. That's where the first dot is. 17.5% is underneath 19.5. The next number on our chart, there was 60% under 27.5 grams of protein. So we're going to move up to here at 27.5, and you can see that there's a big jump. So there's a lot of the data that was below 27.5 grams of protein. But then you'll notice that this kind of slopes off. It kind of slows down here. It goes to 850, or 85% is below this. Now when I say it slows down, I'm kind of telling you that this is getting less and less dramatic. It's not going up as fast. So that might have been a little bit of a confusing statement for me to say. If you're thinking like it's not going down, but it is slowing down. This is 950, and the top here is 975, and then this is going to be 100% right there. So let me put the numbers in so you can kind of see that. Oh shoot, there we go. Sorry that I didn't have that maybe centered well. Alright, so again, to go over this, this is going to be 17.5% was below this. 60% was below this. See if I'm framed up here. 85% is below this. 95% is below this. 97.5% is below this. And then finally 100% is below 59.1. Alright. Now, the last thing I want to talk about is we're going to go back to the histogram for a little bit. And I want to say, in terms of the shape of its distribution, this is skewed to the right. It's skewed to the right because if we talked about this in the previous video, that the shape of the distribution is either symmetric, skewed right, or skewed left. And since this is more skewed to the right than symmetric, that's where we would describe that. And some of your homework might ask you to make a little description of a histogram. Alright, well that ends the second video, and there's a third one coming up to talk about the remainder of the homework packet.